When we get into our circle chapter here in the next, well, starting tomorrow, okay, there's going to be times where we need to multiply things together. There's going to be times where we need to multiply this to equal this, and then we have to solve for x. So before we get into the geometry of it, let's just remember some of the things that we learned last year in algebra class. Okay, so if I am asking you to multiply, okay, so we're going to be on page 1 of this new packet. If I'm asking you to multiply two binomials together, Clark said something about FOIL. Does this seem like an appropriate time to use FOIL? Okay, what does FOIL stand for? We have to take the first product. Yep. So first product, outside product, inside product, last product. Okay. Then when we do that, we need to look for what? Combine like terms. So this becomes x squared minus x minus 6. Yep. Okay, I would like you to do B and C. B and C and stop. You can work with your elbow partner. What?
I think folders.
Nope, they've all been used.
You have a Band-Aid.
Yes, I have some in that, the top bookshelf back there in that colorful, clear tote.
Or is it not?
Did you find one that works? Oh, what'd you do?
Like those folding chairs. It like, I don't know what happened, but it fell and it like sliced my head.
Okay, when we multiply 2m minus 1 times m plus 2. Sam, what did you get?
We're working on it.
Oh. Okay. All right, Sam, got it now?
Plus 3m minus 2.
All right, do you agree? Okay, good. I also agree. Okay, when we multiply out x minus 4 times x plus 4, Harvey, what happens? I want the answer. Okay. Notice how our middle terms cancel out. Why does that happen? So they're opposites. Okay, that's going to be important for us to notice here in a moment. Okay, the reason I didn't want you to do D is because I was nervous you would do it incorrectly. What does x plus 4 the quantity squared mean?
X plus 4 parentheses x plus 4.
Yep. Please make sure that you at least think about writing it twice so that you can multiply it out. My biggest pet peeve is when people tell me that this is x squared plus 16. It is not. It is x squared plus 4x plus 4x plus 16. So I want to see x squared plus 8x plus 16. So the next big thing we need to talk about is factoring. So anytime I ask you to factor, I'm basically asking you to do the reverse of what we did up top. I'm going to ask you to take something that looks like this and get it to look like a product. Okay, we're unfoiling, if you will, but I'm never going to call it that. Okay. So when this happens, you always need to look for a GCF. What does GCF mean? Greatest common factor. Is there a number? Is there a variable that can be divided out of all of the terms and written out front? Okay. Then I want you to notice some patterns. If we have a squared plus b squared, that is called a difference of squares. Okay. Like up top, we had an answer of x squared minus 16. That's a difference of squares. That can be factored to a plus b times a minus b. Okay. Also, what?
How do you just know that? Wait. Oh,
Yes, we're going to call it factoring, but yes, we're going backwards in the FOIL process. Okay. So we know that if we have this pattern, it will always be a plus b, a minus b every time. If we have a squared minus b squared, this is how it's going to factor to. So if you need to make that note, you might need to. Yeah. So if you have them switch like flip-flops, that's fine. One needs to be positive, one needs to be negative though. Okay. Then we're going to talk through some strategies how we factor when we have ax squared plus bx plus c. Okay. So I'm going to remind you of the things that you worked through last year with Miss Kayla, and then you're going to have a chance to practice. Okay. So the first thing I want to look at, A, B, and C. Do you notice how A, B, and C, x squared has a coefficient of what? What's in front of x squared? Okay, there's a 1, right? Okay, so the first thing we do, is there a GCF? No. This has 3 terms. So I know we're going to factor it to look like this. Okay. If the number in front of x squared is a 1, it makes this really easy because we know we're going to have an x and an x. And we know we're going to look for 2 numbers that multiply to -7, or excuse me, +7, and add to a +8. 2 numbers that multiply to 7 and add to 8. Is Clark right? Yes. So x plus 7, x plus 1. Okay. Does this work? When I take x squared plus x plus 7x plus 7, do we get back to x squared plus 8x plus 7? Yeah? Okay, good. Okay, so how about you try this one? You and your elbow partner, put your heads together. We need to factor this. We need to add, we need to multiply to negative 18 and add to positive 3.
Yeah. Negative, oh, positive 6, negative. Plus 6x minus.
All right, what's your numbers? Multiply to negative 18 and add to 3. 6 and negative 3. Is this what you have? X plus 6 times x minus 3? Okay. So how about you factor letter C for me? All right, what are we getting? So x minus 9, x minus 2. Okay. Something that I want you to notice. Okay. If this third number is positive, we know that a negative times a negative is a positive, and a positive times a positive is a positive. Okay. If this number right here is negative, we know we need one of each. Okay. So here we knew that they needed to both be the same, both positive because of this guy. Here we needed them to be the same, but since this was negative, we knew both of them needed to be negative.
You could also do negative 12 plus 1. But that doesn't work for 18.
Okay. All right, what pattern do we have for D and E? Okay, so we only have 2, which makes us question, hey, are these perfect squares? So is x squared minus 49, are those both perfect squares? Yeah. So we can factor this to x plus 7, x minus 7. Well, I haven't taught you anything about circles, so when I say chords and tangents and secants, you have no idea what I'm talking about. So I
know what tangents are.
Do you know what a secant is? Do you know what a chord is? Do you know what an arc is? Okay, so we'll talk about it later. Yeah? Okay, here I have 2 terms. Are they both perfect squares?
Yeah. Yes.
Okay. 11 and 6. So this is going to factor to 6x plus 11 times 6x minus 11. All right, tell me what you notice about letter X. There's 3 terms, there's a number in front. What else do you notice?
So you can divide all of them by 5.
Okay, so we have a GCF of 5 is what that means. Okay? So if we have a GCF of 5, And what we could do is we can write 5 out here, and if we divide it out, what would be left over? X squared plus 11x. Okay. Is that something we can factor? Yeah. Okay, write down what it factors to then.
It's always in this class too.
It's almost lunchtime now.
Wait, does it factor?
Yeah, what multiplies to 10 and adds to 11? 10 and 1. Sometimes the obvious ones don't jump out to us, right?
Or you can make a complex answer, sometimes a simple answer can be correct.
Now, when we go to letter E, I notice again how there's a number in front of x squared, but this time is there a GCF? No. So we have to do a little bit more work to factor this out. There's 3 terms, so we know we're going to be able to do this, okay? But it is not as simple as, ooh, what multiplies to -9 and adds to -12, okay? We can still think about, hey, what multiplies to give us 5x squared? So 1x and 5x. Let's put those there. Okay. I hope you're all using pencil, because at this point, we're going to need to do a little bit of guess and check. Okay. We need 2 numbers that multiply to -9 to go here and here. However, we need to make sure that when we FOIL, the O plus I adds back to -12. So let's just start messing around with some numbers. What multiplies to -9? +3, -3. Okay, so when we multiply this out, what's 3 times 5x? What's x times -3? Do those add to be -12x? They do. Do they add to be -12?
No.
No, they add to be a +12. So when that happens, you know what we can do? We can just flip the signs. Okay. Hey, look at that. We factored it out. That wasn't so bad, was it? Okay. But sometimes you're not going to get it on the first try, and that's okay. Sometimes you're going to have to finagle a little bit until it comes out to work the way you need it to. Okay. So let's try 8. 3x squared plus 4x plus 1. Do we have a GCF? No. What is the only simple way to get 3x squared? Okay, let's do 3x and x. How do you want to multiply to +1? What? How do you want to multiply to +1? +1 or -1? Okay, so when we do that, our inside product is 1x and our outside product is 3x. Do those add up to be our middle term?
Yes.
All right. Then that means our factoring worked. All right, let's look at I. Now, in our other 2 problems, there was only one way to get the 5x squared. There was only one way to get the 3x squared. How many different ways could we get 12a squared? Okay, so that we might have to be patient. My suggestion, if there's more than one way to get a product, start with the two that are the closest together. So let's start with 3a and 4a. Okay. How do you want to get -2? -2, +1? Okay. All right, so when we do this, we get an inside product of -8a and an outside product of +3a. Do those add to be our middle term? But we just need to flip the what? The signs. So that this is a positive and this is a negative. And now we're okay.
I put the 4A and 3A, and I had to refill the signs.
Yeah, if you get the opposite of the middle term, you just need to flip the signs and keep everything else in place.
Yeah, I did 1, 2, and 3A.
So then you had to flip a lot of these. Yeah. All right, go to the back side of that page. Okay, now we're going to talk about solving an equation. If I ever ask you to solve an equation, and this is really where things are going to come into play throughout the next couple weeks with this algebra. If I ask you to solve an equation and there's an x squared, you have to make sure it equals 0. Okay? Does this equal 0? Yes. So what we can do is we can factor it. Okay? Notice how this is a nice one because we have a 1x squared. So we can just do simple. What multiplies to +6 and adds to -5? So we have x minus 3 times x minus 2. Okay. Well, hey, if I have x minus 3 times x minus 2 equals 0, then what we can do is we can say, okay, x minus 3 equals 0 and x minus 2 equals 0. Do you remember doing this? Okay, so what does x equal? 3 and 2. It's actually what we're doing right now in algebra. What, Nora? Oh, that's. Okay, let's look at this next one. Is this one set equal to 0? No. So we need to subtract over 30 so that now it does equal 0. Yeah, that would be cool.
Yeah.
All right. Sam, I need two numbers that multiply to -30 and add to -1. Multiplies to -30, adds to -1. What are some things that multiply to 30?
5 and 6.
Oh, 5 and 6.
Dude, I was thinking like 15 too. That was bad.
So it's x plus 5 times x minus 6. Well, if we have x plus 5 times x minus 6 equals 0, then what does x equal? -5 and 6. Because we say x plus 5 equals 0, and we say x minus 6 equals 0. It's all coming back? No? I promise you. I can show you the test I'll give. All right, now this one. What do we need to do with this one? What do we need to do? Okay, so we need to add 2w and add 2. So we now have 9w squared. I'm going to add 2w. And I'm going to add 2. Well, now remember, if we have a coefficient in front of the squared term, we have to kind of do guess and check. So what do you want to multiply to 9w squared? Let's try 3w and 3w. What do you want to multiply to get 2? See if it works. This gives me 6w and this gives me 3w. Does it work? Okay. So once we get it factored and we're set equal to 0, we can say 3w plus 2 equals 0 and 3w plus 1 equals 0. So when I solve for w, I get negative 2/3 and negative 1/3. What then? Subtract the 2 and then divide by 3. Subtract the 1 over, then divide by the 3. Right? All right, last one, letter D. Super weird. What's happening here? Can I say x minus 1 equals 18? And x plus 2 equals 18?
No.
No, because it has to equal what? 0. It only works if we equal 0. So what do we have to do on the left side? We are going to have to minus 18, but it's not going to help if I have x minus 1 times x plus 2. We need to FOIL. We need to FOIL. We need to unfactor. That's FOILing, right? So I need to take x times x, x times 2, negative 1 times x, negative 1 times 2. And then we can subtract that 18 over so that we are set equal to 0. Two numbers that multiply to negative 20, add to positive 1. So if x plus 5 times x minus 4 equals 0, then I know that x equals negative 5 and a positive 4.